Hey guys, welcome back. Houston Math Prep here. In this video, we're going to talk about the definition for prime and composite numbers, and also look at a way to write composite numbers as multiples of primes. So let's start with our definition. Any number with exactly two whole number divisors, that is 1 and itself, is what we call a prime number. So an example of some of the first prime numbers are 2. 2 can only be written as 1 times 2. Or 3, which again can only be written as 1 times 3. 5 is only 1 times 5. So these are some examples of prime numbers. Thinking about kind of the opposite of that, any number with a whole number divisor other than 1 and itself is what we call a composite number. So an example of that might be like 4, 6, 8, 9, 10. 4, as an example, can be written as 1 times 4, but it can also be written as 2 times 2, which means 4 has the divisors 1, 2, and 4. So because it has a number other than just 1 and itself as a divisor, 4 is a composite number. We have the property that every composite number can be written as a product of two or more whole numbers greater than 1. We call the product that we can create the prime factorization of that composite number. The Fundamental Theorem of Arithmetic tells us that this prime factorization that we can create is unique for each number other than a potential rearrangement of the primes. So let's take a look at a couple of methods for finding this unique prime factorization. The first method we're going to take a look at is what we call a factor tree. So let's take the number 124 for example. We know that 124 is a composite number. I know that just by looking at it because it's even. So I know that at least 2 divides evenly into 124. So I'm going to split 124 into 2 factors. Now what those factors are doesn't matter as long as it's something other than 1 and 24. So one option would be to divide by 2 and say that 124 is 2 times 62. You could also do 4 times 31, and that would be okay too. Since 2 is a prime number, we're going to go ahead and circle that, and that branch of our tree is finished. 62, however, is not a prime number, so I can again split it into 2 factors. In this case, 2 times 31. Now again, 2 is a prime number, and with some checking, we can see also that 31 is a prime number. So 124 can be written as 2 times 2 times 31. Or if we wanted to use our exponent rules, we could write that as 2 squared for 2 copies of 2 times 31. 2 squared times 31 is the prime factorization of 124. Now, another method of finding the prime factorization is what some people call a factor ladder, or sometimes called a factor stair. In this case, we take 124 and we divide it by whatever prime number we can think of that goes into it. So again, because 124 is even, we might start with 2. So we'll draw a little half box around 124. We'll put 2 on the outside, or whatever prime we're going to work with, and then our result underneath. So 124 is 2 times 62. Now we continue until we're all out of primes. So 62 is even. So again, I can divide it by 2 and get 31. 31 is a prime number, so all we can do is divide it by 31. And now that we have a 1 at the bottom, we know we are finished. So that means 124 is the product of all the numbers down our ladder here, or 2 times 31, which again can be written as 2 squared times 31. All right, let's try finding the prime factorization of another number. This time, how about 420? Now, if we start with the factor tree method, we might choose to first split this number into 10 times 42. Or maybe you said, hey, that's an even number, so you might start with 2 times 210. Either way is totally fine. Now, I need to split each one of those that is not prime further. So 10 becomes 2 times 5, and 42 becomes 2 times 21. 21 is not prime, so we can further split that into 3 times 7. Now, the ends of all of our little branches here are prime, so we know that we're finished there. If we wanted to see the factor ladder method for 420, this is what that would look like. Remember, we divide by whatever primes we can easily see go in until we're down to 1. So we have our two methods for finding the prime factorization of 420 is equal to 2 times 2 times 3 times 5 times 7, either from the ends of our branches here or the outsides of our ladder here, and we might condense that to be written as 2 squared times 3 times 5 times 7. Alright guys, that does it for this video on prime and composite numbers and some methods for finding prime factorization. Until next time, we'll catch you in a future video.